So today's session is artificial intelligence. So before we start on the topic, let me introduce about myself. So my name is Rushikesh Meherwade and I have total 10 years of experience in the IT industry. Right now, I'm working as a manager of data science in a company called as a Morningstar. So Morningstar is a equity research organization which tries to do research around different companies, around different exchanges around the world. And they do provide information for the investors so that investors can make a better investment decisions. So we work in a data collection team there where people try to collect the data from this lot of different reports. So what usually happens, different companies try to publish annual reports, quarter reports, press releases. There are this various types of reports which are there that every company has to publish as per the regulations. So we in the data science team, what we actually do is we do help automate extraction of the data from this unstructured document. These are like PDFs, HTMLs, tabular based data, paragraph based data. So we do use machine learning to extract information from these documents. What usually happens is it requires a human with some domain knowledge in the finance to extract the information from the documents. It's not that easy directly we can automate. For example, when someone says that, okay, the company has earned this much, the company has lost this much. So those things will be present as part of a table with a different language, with a different presentation. So we use AI to deal with that. To give brief more on my career perspective, like I've been like initial 5 years of my career has been into the testing. I was in performance testing. Then I did a 1 year of part-time course in machine learning data analytics. And then I started as a senior data scientist in Morningstar, then lead data scientist, and right now working as a manager of data science. On top of it, I've been doing training from last 4 years, been doing various types of training, classroom, corporate, uh, trainings in Python, machine learning, deep learning related topics. So that's a brief about me. So let's get started. This image that you see looks like a jungle, and you may have a question that, okay, why in an artificial intelligence session we see a jungle? So this field of AI for anyone who starts as a beginner will look like a jungle. You don't know how to traverse through it. You'll see everywhere there are trees and trees, everywhere there are obstacles. There are so many things to learn. There is a math, there is Python, there is machine learning, there is statistics, there are so many things. How do we get started with all of this? How do we reach the end goal so that we can start applying these things? That's what we will see a brief today. Okay, so before we start, can anyone tell me here over the chat, what is machine learning as per you? Over the chat, you can just type, what do you think is machine learning? Anything. Shashank says extracting patterns out of the data. Great, yes. Let the machine learn some particular processes. Okay, that's great, Nishant. Lalit Mohan says instructions for machine. Okay, cool. Close. Yeah, anything else? Is this what you guys all feel about machine learning? Kurunji says understanding and building methods that learn, that is methods that leverage data to improve performance on some set of tasks. A very good description of it. Do complex calculations for a long period of time. Okay, that a slightly different definition. Okay, great. Sagar, continuous learning, implementation like human, machine learning, the data would require the model. Great, great. All of you guys are, some have very good answers, some are close by, but yeah, that's great. So let's see from the definition perspective, what does the machine learning really look like? So the first definition, which is a general definition, let's see how it goes. Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. So machine learning is an application of artificial intelligence. Artificial intelligence in itself uh, basically means we want to automate everything that is similar to the humans. Whatever human as the intelligence we have, we want to mimic that human intelligence to the systems. So if we can see the things, we can perform some action over the, uh, like right now, you all are able to see what I'm presenting and also able to hear me what I'm saying. So all of this, we as a humans are able to do easily. And just one question, like whatever the learning that we do, for example, if someone tells you that a kid, when it learns that, okay, see, this is a cat versus this is a dog, okay, and if you just show it 1 or 2 times, the child will be able to, anytime a new cat or dog it says, it will be immediately able to say that yes, this is a cat or dog. But with machines it takes a time. But now I have a question. Do you think this learning of a child which is there, or this experience that the child has, is it just from the ground up? Like for example, the moment it is born, is it born with all this intelligence, or it is just from the scratch? What do you think? The child, is it learning completely all from the scratch, or is there anything else? Any idea? So child learns it so fast. Yes. Yeah, DNA and everything, right? Very true. So see, what's happening is we as a humans have evolved over this so many years. Humans have been learning. So the brain, or the brain information that we have, it's already containing a lot of learning. So every child that comes, it already has this DNA based information available, and it is easily able to adapt to that information and go ahead. So we as a child, when we start learning, there is already some set of learning we come with. Whereas when we try to teach it to a system, the system, it is not that easy, because system has to learn it completely from the scratch. It does not have any kind of a historic learning. So as a AI, what this AI really does is, AI machine learning right now goes in a very hand to hand. So we will use them as an interchangeable thing. So artificial intelligence in this case is trying to learn through the system. It provides the system the ability to automatically learn and improve from experience without being explicitly programmed. Now you may have a question that, okay, we are not programming, then are we not using any kind of a programming language? It's not like that. Historically, how we used to create any kind of a system is if else conditions. We say that, okay, yes, if this thing happens, you do this. If this thing happens, you do this. We used to program it with every set of instruction. We provide it with every set of instructions saying that, okay, if this happens, you do this. If this happens, you do this. In case of cat and dog, we just simply say that, okay, if this kind of curves are there in the image, if this kind of a nose, if this kind of an eye, if this kind of a fur, tail, then this is a dog, or this is a cat. So defining all this explicitly, we used to do it beforehand. But now with the advent of AI and machine learning, what really happens is we try to provide it the experience, the way the child we try to train, saying that, okay, so this is a cat and this is a dog. To the system also, we try to provide with the examples. We provide it with the examples by which it tries to understand, okay, yes, this is a cat, this is a dog. We give it hundreds of examples. We say that, see, these are the hundreds of cats and these are the hundreds of dogs. And then it tries to learn over that data. That's where it tries to mimic that human intelligence. Now, if we go a bit more advanced definition of the same thing, a computer program is said to learn from experience E with respect to some task T and some performance measure P. Now, let me break this down. So experience for a system is nothing but a data. We as a humans, when we are trying to see experience, for us experience is nothing but some events, and through those events there are some memories. But for system, it is nothing but the data. It is all stored as the information data. So here it is trying to learn from that experience, which is data, with respect to some task T. Now, the same example, if you go identifying a cat versus dog. So here the experience is learning and differentiating them. That is also the task. Task is basically how do we differentiate, and experiences as we try to show it more and more examples of that same data with the variations. Like we try to show it with the different variations that see, this is how the dogs look like and this is how the cat looks like. And then there is a performance measure P. So performance measure is how right you are able to identify it. There is 80% performance, there's 90% performance, how accurate you are able to identify it. At the start, your system will not be able to do it very well. When you only show it like, okay, 10 images of dog, 10 images of cat, it learns, but may not be good. Then you try to improve that again some more by providing it like 50-50 examples. Then you try to again provide more examples. As you provide more and more data, the systems gets more and more better over its performance. As measured by P, improves with experience E. So this things, as you keep providing it with more and more experience versus data, its performance keeps improving over the given task. That is differentiating things. So as part of AI, I'll show you one very good video right now that you'll see like how good the current AI systems are able to work on. Give me a second. Yeah, if not here, I'll just show it over the browser. Yeah, so just have a look. So what you see on the screen is one of our AI models that is able to differentiate between the different images. This is live model. This like live means we can download the model from the internet and run it on any video, and this kind of object will be easily able to identify. If you see, there are so many objects present in the image. Even if there are like some 150 people are standing, it will be able to easily identify those information. And one more thing that you see is there are sometimes confusion. It's not always 100%. If you say sometimes it identifies the truck, sometimes it doesn't identify person, it also sometimes misses that data. So the systems are currently not 100%, but there is a good performance. As you see, it is able to identify the suitcase, car, person, truck. There are so many things it is able to easily identify. Even in the Indian scenarios, this is able to locate this data very well. And people are using this kind of a technology for a very good use cases. For example, how do we identify how many people are coming in the mall and going out? How many people are visiting? How it is changing? Managing the traffic through identifying these cars. That okay, how many cars are coming? How do we manage the traffic? How do we automate the signal detection? Those are there. And also in the manufacturing industry also, this is being used highly right now. In manufacturing industry, whenever the products are being built, they identify the quality of the product. They learn how good the quality is by looking at the object, whether it's good quality, bad quality, what is the current phase of the product, like it is in the work in progress, what are the parts being developed. So those are like different applications that this kind of a technology is being used right now. Yeah, so see, if you see, it's even if the previous example was uh, camel, it was detecting as a horse. Yeah, so even you can run this kind of a system. Once you learn like how this works, you will be able to load this models and run through this and see like, okay, you will be able to detect these things even on your local system. Yeah, even if there are so many people. Yeah, so you may think that this is being manually drawn. No, this is being drawn by the system. And anyone can run the system who knows a bit of Python and the machine learning, artificial intelligence details. They can run this kind of a model easily. Okay, so that's one of a thing, that is object detection. Now, yeah, we'll come to few more things. Some more example is like this is about the textual data. Hugging Face, let us just see. So Hugging Face is one of a Python libraries, which is a very well-known library in the field of machine learning. And this one shows like how good the systems are able to generate the natural language. And you will not be able to distinguish between who's right, like how is it being developed by the system or it is being written by a person. For example, once we say that once upon a time, before I got my hands on the whole story, before I made my very first trip to Haiti, I used to think there must be a better way. So if you read through the sentence, you may look like this is being written by a human, but this is fully being written by a system. It's humans are not at all touching it. The whole data is being written by the system. I can change it. For example, I can say Maharashtra is, let me see if it does something here. I don't know. Is in the midst of a major health crisis as a result of unspread of hepatitis C infection. Yeah, see, it's sometimes may not make sense. But the thing I'm saying is the thing that it is generating, the sentences, the words, the way it is able to recognize this, the grammar, it is able to create the grammar. You will not be able to distinguish between whether it is from a person or it is from the machine. That is the quality of data that it is generating right now. Even we create like question answering based systems. So there are like, I can also show, and these are like some Python models directly available. For example, you see a code available, like you can just generate, yeah, there are some code examples in this. So this is a Python code we can run and get this kind of a system running. We can train it on top and we can create our own models. So let me also show one more thing. Just a second. Yeah, not this one. Yeah, there are some models that can just recognize the paragraph, and from the paragraph, it can give you question. Yeah, let us see if we get something. We'll just see some examples for this. Yeah, they just have a good tutorials. Now this is for the data set. Yeah, these are just some simple outcomes. Like if you see, I'm giving a question and also a paragraph. And from this paragraph and question, when I'm asking a question, it is able to respond with the answer. So example, we can just change an example. So here it says, what is my name? If I run, it will tell me that there's a Clara. If I say, where do I live? So if you see, it comes up with the Berkeley with the confidence percentage coming up here. We can even put the whole paragraph here and ask it with the different questions, and this model will still be able to come up with the answer. So for example, now this is the one, this is like a big paragraph. So if we ask it some kind of a question, it will be able to come up with the answer. The rainforest in English, what is the name also used? Yeah, so this, I'm just trying to show some kind of a use cases that is happening in the field, which you may think that, okay, may not be very right, but that is actually happening in the industry. So systems are being developed, which are so well in understanding the human language and also understanding the computer vision. And as a human intelligence, if you think of it right now, you as a major part that is doing is you're trying to see the screen and also trying to hear me. Now my sound can be considered as a text, audio to text, you can consider this as a text, and then your visual. These two are a very core components of our human intelligence, seeing the things and listening to the things. And that part is being developed so well with the AI based solutions that we have in the ML space right now. That is changing the whole way the people have been developing the technology still now. If we talk about the applications and in the different industries, you all may be coming from the various industries here and may also already be experiencing the advent of AI own fields, because there is no space or no industry that I have seen till now where the AI or machine learning is being applied. So be it a finance, where in finance you can say that, uh, as I said, creating the chatbots. There are very interesting chatbots being there who can understand the human language, and they can tell you that, okay, what products you should be buying, what products you should not be buying. The chatbot Siri based systems, that is all like a different thing, but those kind of systems are there in finance space, coming up with the forecasting, how the forecasting can go for the stock market or stock identification, what to buy, what not to buy. There's a good amount of AI being used right now. Healthcare is a very important space right now. If you think of it, the number of doctors which we have and the number of people that we have, if you compare, the number of doctors are very small in size. So we don't have enough doctors in the overall world to cater to all the different diseases and problems that we have in the world. So augmenting for the doctors can be a very great thing with the artificial intelligence based systems. The way you saw the object detection of person and car, nowadays even X-ray scanning, the AI based systems can identify what are the diseases, what is the cancer lump, what is the problems with the X-ray. So all of these things that doctor used to do manually in identifying the diseases nowadays are being done by the AI systems. Agriculture, trying to identify how to provide water, how much to provide water using IoT based devices, and gathering on a continuous basis the data from the IoT devices, like, okay, temperature sensors, the humidity sensors, the sunlight sensors. So all of that considered, the data is being used to decide how much of a water, how much of a the chemicals and all should be added so that these plants can provide optimal optimal outcome in terms of the raw materials. So agricultural space is also seeing a very good use case of the AI there. Education is seeing a very good use. I don't know how many of you have seen, one of like 1 or 2 years back, there was one video being circulated that in China, there is a school where people are provided with the head. Uh, there is this head, I would say, a headgear. It's like a helmet that tries to monitor your brain on a continuous basis. And when children are sitting in the school, they are put with this helmet. They have to sit the whole time with this helmets. And teacher have a computer with everyone's data being logged, where the teacher can see who's focusing and who's not focusing, who's sleepy and who's not sleepy, what the child is doing, what is the amount of uh, effort the child is putting. So all that detail comes on the screen of teacher, and teacher can immediately see who's facing challenges and who's doing good. So you can imagine the amount of data that can gather and help students to improve, but there are both goods and bads to this. I would say whoever has already completed the schools and colleges, that's really good, because over the future, the way the education has been done may change, where this helmets right now that we have may not be that big, but those will come as a smaller pieces, but every student will be monitored for their progress with a good set of technologies, IoT devices. So those kind of changes will happen, and automatic suggestions and all those things will be given to the students. So that is one space in the AI education. Social networks, everyone would be aware of the social networks. Yeah, just that education video, that Chinese video I was talking about, has anyone seen that? Like, they put the helmets and they can monitor the whole thing. Has anyone seen yet with that video? Yeah, Manu says he has. No, so I would highly suggest try to see. I don't have a link for that, but you can search that. Okay, China using head helmets to monitor the students, something like that. But you'll absolutely get it. A thing to see, I would say, like how the future could be. That you say yes, good, bad, however. But I am assuming those are the things which will be there in the future. Cool. Social media, we all know that is one of a very common thing that we usually go through, be it Instagram, Facebook, LinkedIn, Twitter, all of these cases. We have you the interesting things that you are more interested in. So you will be getting the recommendations for the things you like. Even according to that, the ads and all will be popped up to you, and even a content that, okay, you have some people you usually like their content, only their content will be given to you. So those kind of recommendation systems are there in social networks. That is also part of uh, the AI-based systems. Then talking about e-commerce, everyone uses Amazon, Flipkart, Myntra, this e-commerce based applications where you try to buy. Nowadays, I think after the COVID, many people have started to use e-commerce based products to get the data, be it even uh, like all of this, like product selling, cross selling. So all of this is very good part of a e-commerce. Like e-commerce is a very big industry that like this artificial intelligence systems, the recommendation systems is being used highly effectively. That's a very big market, and you will see everywhere the e-commerce is one part, but I would say even if you think of a Medium website, LinkedIn, all of this are in a very similar line. The social networks and e-commerce are having a bit of the boundaries where a similar type of recommendation systems are used to provide you what you really want based on your history. It will check your own history and then will give you what you actually want. And those are called like a customized recommendation system where you get a customized outcome based on your likings. Okay. So now, how is this AI and other different technologies that you usually hear about are interlinked with each other? So the first is artificial intelligence. In real term, the artificial intelligence is a general field which just says that how do we mimic the human intelligence? There's nothing else. This term has been there from like almost 1950. Around 1950, this term is there where people started with the thing that okay, how do we mimic the human intelligence? But the definition of artificial intelligence has been changing from decade to decade as people have been moving. At the very start, when 1950, it was purely just creating a rule-based systems to still mimic the human intelligence. Now we are growing more and more toward advanced applications in the artificial intelligence. And as I said, we as a humans deal with a lot of different activities in our brain that we even not aware of. Like there's the decision making, the way we try to manage our body parts, the way we try to see the things and take the decisions. we do language processing, language translations, speaking, understanding things. So there are so many things as part of artificial intelligence. So artificial intelligence is a general concept. It's more like a concept than a technology. So artificial intelligence just says that, okay, how do we mimic the human intelligence? So to deal with that, we have those different systems, that is machine learning, deep learning. So as I said, AI is a general theoretical umbrella that involves a lot of things. And within that, machine learning and deep learning are like a technologies that helps us achieve what we are dealing it as a artificial intelligence. So in this also, machine learning basically says, how do we use the data to learn the patterns out of it? And once we learn the patterns, how do we use these patterns for the future so that we make a forecasting, prediction, decision making, all of those, how do we do that? So machine learning purely deals with the data. It uses the data. So see, as a human intelligence, even if you think of it, we also are just learning from the experiences. We are also learning based on whatever is uh, given to us. We just see the things, we experience it, and then recognize them. And whenever it again repeats, we try to do the similar activity. But we humans are much adapted, evolved over the years, but the systems are just doing. So machine learning is purely about the data, use it to create the patterns, and then how do we leverage those patterns for the future prediction. Then comes the deep learning. Now, deep learning has a variety of names. Deep learning also is called as a neural networks. Neural networks, as you all may know, is about this human brain. Our brain has billions of neurons inside our brain. And all these billions of neurons are connected with some uh, neurons are almost connected to millions of neurons. Some neurons are connected to a different number. So all of these neurons are connected to different subset of neurons. And in our brain, we have those different sections like prefrontal cortex, motor cortex, so hypothalamus. So there are like different uh, areas inside our brain which does a different type of activity. So around the neural network also as a concept has been there from almost 1970 or 80, when people created a one single neuron. They started with a one single neuron, and then they stopped around that time because the systems were not that easy to scale. It required a lot of compute and also the data. So around that time, the data and compute was very less. So deep learning actually started taking a boom around 2012. So there were few papers that came that really changed the overall picture of the deep learning. So earlier, people who were not able to use the neural network, now they started to suddenly use. Why? Because there was a good data available. People have started storing the data. When the big data started, with the big data advent of big data, people started to store data. They got, like, some of the companies started to see the benefit of storing the data. So they started to collect this data over the time. And then the machine learning came into the deep learning came into the picture, because there was a data and these technologies can be applied to learn the patterns. So this 2012, there came a lot of different algorithms in deep learning, like uh, the artificial neural networks, convolutional neural networks, recurrent neural network. These are the different things that came around that time. And from there, it has been going on and on. Deep learning is also synonymously uh, replaced with artificial intelligence. So people call deep learning artificial intelligence uh, in a similar context. Why? Because deep learning made a lot of changes to the tasks related to the image and text. That is computer vision and NLP, computer vision and natural language processing. Deep learning started to make a lot of changes around that. Like, it solved a lot of different problems which were there earlier. We were not able to solve, but now with the deep learning, we were able to solve. So it gave us a very closer to the human intelligence perspective. But now the definition of artificial intelligence and deep learning is very similar nowadays. People are tagging them in a similar way. So the original definition, the umbrella definition of artificial intelligence has lost. So to again keep that original definition of a theoretical AI, people have created a new word that is called as AGI. You will hear this term a lot, artificial general intelligence. Has anyone heard of this term? Artificial general intelligence? Anyone here who has heard of it? Yeah, I see some are yes and some are no. But yeah, I would highly suggest that you should have a look at this, because now the general definition of the artificial intelligence, like as I said, AI is like a theory which says how do we mimic the human intelligence. It's not that easy. It includes a lot of different pieces. So now the deep learning is synonymously called as a AI because it solves a very important and complicated challenges that were part of artificial intelligence. Cool. So let's move on to the next topic. What all do we need to get into this field? Now, in general, to get into this field, I would suggest you need to learn Python as a first topic. So Python is a very important language that has just changed the whole programming language landscape. Earlier, it was only like Java, C++, .NET. These were the top languages. Nowadays, there are many different languages like Python, R, Julia, Go. There are different type of languages available, and Python out of them is like at the top right now. It has changed a lot of perspectives in many different companies. You will even big companies, Google, Amazon, Microsoft, NASA, you name it. Every company nowadays uses Python, and Python skills are scarce in the industry, and Python knowledge is very widely being looked up right now. You also need to understand how to do the data analytics. As I said, it's all about data, be it computer vision, NLP, tabular data, database-based storage data, anything that you see, everywhere you need to do some analytics. You need to understand the data. You need to get deeper into the data and see what are the patterns. If there are patterns, then only your system will be able to learn. This is like garbage in, garbage out. If there are no patterns, then your system will not be able to learn. But if there are any patterns, it will be able to learn. We sometimes just give the data and let the system learn these things, but that could take a lot of time. You will get to know, okay, this is not available, okay, let's add this. This is not available, let's add this. That takes a lot of iterations. So if you do the data analytics by yourself to some level and then take it ahead, your outcomes would be much faster. So data analytics is very important. It could be through some libraries that are there in Python, that is NumPy, Pandas, Matplotlib. You can use other things like Spark, Hadoop, big database systems, ETL, SQL. So all of that will fall under the data analytics that you need to learn. Then comes the visualization. In the scenarios, as you need to deal with like a humongous amount of data, it could be like some billions of rows of data, thousands of records. There, trying to go through that data one by one or looking at that data at a high level is not that easy. You will miss things, and it's not easy to understand that whole data. So visualization plays a very important role. So visualization, there are tools like Tableau, Power BI, ClickSense. There are different type of tools available in the market, which like many companies use. Those are paid tools. And also, if you don't want to go to the paid tools, there are also non-paid tools, open source tools, like Python has Matplotlib, Seaborn, Plotly, Dash. There are the different type of libraries which will help you to do the visualization. Then we have maths. Now, what all maths should we learn to go ahead? Okay, so maths. How many of you in your work life thought that maths was not useful? Anyone here similar to me who thought that after completing the college, maths is not much useful? Anyone here who was of that opinion? Yeah, but the college math that you learn, the statistics, the calculus, Fourier transforms, all of this fancy maths things that we learned in the college, was that useful to anyone after college? Right? As I see many people says here that these things they were not able to use. Even I was in a similar way. I was like a kitty person in math when I was in college. I had a KT in math. As a maths background, I did not have a maths background. I was a diploma student. When diploma people, even people who are here from engineering background, they'll know that people who move from diploma to engineering, they face a lot of challenges uh, when they come to maths. But the challenge that I saw is in our college systems, we don't get to see the applications of the maths very well. It's not the mathematics that is important, but the application which is important. It's not important that how you solve it, but more of where that kind of a application, where is statistics used, where is calculus used, where is Fourier transform used, where is this Laplace range used. So how is this thing used? That is more important. And I feel that those kind of things are not taught in the college time. But when I started to learn for the machine learning and things, I started to actually learn again maths, like calculus, statistics, linear algebra. And then I saw the real applications for these things, like how statistics is being used in many of the data analytics to understand the data, how statistics helps in summarizing the data. You have a huge data. How do you summarize the data and try to identify issues in the data using statistics? Then come up with the calculus like differentiation, integration, how this is really useful in your real world. Like how, for example, in the deep learning uses calculus to a great extent. Even linear algebra, the matrices, the determinants, inverse of matrix, everything is being used in the deep learning or even normal machine learning based applications where we do the system internally does the mathematics of doing the matrix multiplications and other thing. So having that basic understanding would be required here, not a very high level. As I said, we don't need to know how things are solved. There are there are libraries and things which will help you to solve many of the things, but you need to do is you need to I would say understand what is useful at what place. That is more important than understanding how it really works. More than that, I would say where it is applicable. That is more important. So that basic understanding of, I would say, statistics, calculus, even in calculus, just the differentiation, partial differentiation, and then linear algebra. These three things are very important. These are like required maths background. Not maths background, I would say, but the basic working would be required there. But when you start learning the applications, you will really like the maths. That's the beauty. But we don't get to see that beauty in the college time. Yeah, that's what I have understood. Cool. So those few things, and then getting into the machine learning. So now to get this AI-based systems, learning the machine learning is very important. Like how those machine learning based systems are learning the patterns out of it, what are the different algorithms available, how do we run it, what is the train, what is the testing stage. So there are like different stages that you need to learn for the machine learning based applications. That is a core part of machine learning is like a core part here. And then deploying this application. Many people learn machine learning, but they don't understand how the systems are actually deployed, how this are actually being used. So understanding, once you learn the machine learning, you need to understand how these things are actually deployed. That is again a very important thing. And then a bit of software engineering. how the software systems are built. Because these applications, AI-based applications, are nothing but the softwares. In general, they are just a software-based systems. So to actually create them in a well way, you also need to understand the software engineering to some level. Software engineering is a field that comes more with the experience. As you keep developing more and more software products, you get good in the software engineering. But yeah, some basic understanding of this would be required. So these are like all different components that you should be good with to get into this field. Not completely everything master of it, but at least get a good gist of everything is important to get into this field. Absolutely, Nishant. So see, the industry has these terms created in a confusion level, but to be frank, AI, machine learning, data science, all this are very similar to each other. And I would even say this is just like a different names to the similar thing. Just the data science is like a bigger thing. Bigger thing means it involves everything around data. Now, data science is not just machine learning. Data science is big data, Spark, Hadoop, your machine learning. So everything that is around data is part of your data science. So data science has this broader picture around everything related to the data. Machine learning is only about with the data, how do we create this predictive systems. AI, as I said, has some slightly bigger perspective, which says that, okay, how do we mimic the human intelligence? But these are all like interconnected to each other to a good extent. There's a good overlap between all of this. Absolutely. ML is part of a data science. Yes, that's very right, Nishant. Now, uh, coming to like as ML is a bigger part, like it's a very important part of all of the system being AI, data science, all of it, ML is a very important component because that's where you create this predictive, learnable systems which you can train and utilize. There are three major differentiation or three major types of problems that we solve with machine learning. So everything that we create in this falls under this three categories: supervised, unsupervised, and reinforcement. These are the three different type of learnings that we have. Supervised says that, okay, in the school, when you try to learn something, let's say you usually when there is a semester or let's say there is a year, and within this year you try to learn a lot of different concepts. Also you try to do a homework with, okay, this is the question, this is the answer, this is the question, this is the answer. Some people by heart or just they just memorize the question versus the answer exactly. Okay, that happens in these school days. We just know that, okay, this is a question, this is the answer, this is a question, this is the answer. So even if in the actual final exam the question is twisted, people who just memorize the question versus the answer, they may not be able to perform well. So the way in the school 1 year we do try to learn the different concepts and understand them. That's what like we supervised learning works in a very similar way. So we try to train that with the different patterns over the time. For example, we try to feed it with multiple images and we tag every image saying that, okay, this is dog, this is cat. Every image is tagged as saying this is dog, this is cat. And you learn the differentiation between them. Some more examples are like, we can say that we can give it a set of customers, okay, some thousand customers, and we say that, okay, this customer is buying and this customer is not buying. You learn the difference between which customers are buying and which customers are not buying. And then whenever I give you a new user, you need to tell me who is going to buy and not. So supervised learning, we try to feed it with the data versus a target. That, okay, this is the data, this is what we want to learn out of this data. For example, we want to learn whether this user is going to buy or not, whether the stock is going to up or down, whether the customer is a defaulter or not. So things like that, where we want to identify from the given history for this data what is going to be the outcome. Okay. And then in the future, we'll only have this data and we want to know the outcome. We want system to generate this outcome. That's where we have the supervised learning algorithms. Again, there are multiple types, multiple algorithms within supervised learning. That is a different thing. Unsupervised learning, we don't have any kind of a target. We don't have to say that, okay, this data is should be tagged with this data should be tagged with this kind of information is not there in unsupervised. Unsupervised is just a data. We just get the customer's data. We don't have anything like, okay, this customer is buying, this customer is not buying, this customer fraud. There is nothing like that. It is just purely a data. And we just want to find out some patterns. One of the type of pattern is clusters. So given a set of customers, how do we identify the grouping of the customers based on their different type of features? So that is unsupervised. Yes, Preeti, like we can give it a new raw data and then the system has to identify which cluster it belongs to. Now, if we talk about unsupervised, we can provide it just the raw data. Yes, as you say, we can just provide it with the raw data. And from this raw data, the system has to learn the pattern by itself. It has to just identify how those things are similar to each other, who all are similar to each other. So those things fall into unsupervised. There are many different things like we have anomaly detection, outlier detection, clustering, market basket analysis. There are different type of algorithms which falls under unsupervised learning, PCA. There are different things. So the goal of unsupervised, there is no supervision. There is no target that we want to learn about the data. It is just a data and we want to learn some pattern out of it. Coming to the reinforcement learning, this is very similar to the way we humans learn, the way we humans learn in the environment. For example, if you think of a kid in its childhood tries to learn to walk not from the day one. It takes some time. If you have observed kids, like how do they learn is they'll start observing the adults. They'll see step by step that, okay, how the adults are walking. It start standing on its leg slowly. It'll see that, okay, people are standing on the leg, I should also do. But you will see many times it falls. At the start, it will not be, the kid is not able to identify how to balance its body. So over the time, it tries to do this multiple times till it is finally able to stand. Standing is the first step. Then it again has to start walking. But again, while walking, it will fall many times. It has to create that balance again. Then again, it fails. So this process of trying and failing and learning and then coming to know what is the really right thing is part of a reinforcement learning. So driverless cars are like a very one of the important use cases in the reinforcement learning. I'll give an example. Like reinforcement learning is also being used nowadays to automate many of games. If you guys have heard of Dota and Dota is one of it, Open Quest. There are some few games, the chess. So there are systems that have been created which have actually defeated top human players uh, in their games, okay, by the systems. They have defeated the top players. So this reinforcement learning, how it really works is you provide it an environment. That environment has some conditions. Okay, for example, a driverless cars. So this driverless car is put in a simulator and the simulator tries to provide a complete environment. And you try to provide all the rules. You tell the car that, okay, you should not cross a signal. If you cross a red signal, then you will be given a penalty. Okay, and if you cross a green signal, you will be rewarded. If you try to bump into a person, you will be penalty. If you try to stop when the person is there, you will get a reward. So like this, some set of penalty and reward based system is created in a given environment. And the car, the car in the simulator just need to keep going and understand that, okay, where it is getting a penalty, where it is getting a reward, and try to maximize the rewards as much as possible. So it will do all the trial and error. Okay, it will keep on doing everything possible. And then at one point it sees that, okay, if I do this, I'll be able to get a higher reward. So I'll keep doing it. But if I do this, is a bad thing, it's a penalty, I should not do it. So this kind of a learning we try to embark to the system using the reinforcement learning. In the reinforcement learning and learning, there is no data, but the environment has to be created in a very fashioned way so that all the rules and conditions are there. For humans, for us, this whole earth is like an environment where we get to learn that when we do something right, when we do something wrong, we get our penalty and rewards, and then we learn from it. That's how this reinforcement learning also works. It's like a very high level definition of all of this. Okay, moving ahead, coming to this, what is a general ML? So what is a general ML life cycle? So ML, or as I said, like any artificial intelligence system, okay, the data science project, all of this, as I said, are like very similar to each other. So the general life cycle that is followed in all of the systems is we first start with the business understanding. What is the problem statement? We do try to understand the problem statement. So the problem statement may say that, okay, we want to, the first example that we saw, the video example where it was able to recognize the humans very well. Let's say the system has to recognize the humans in the given image. So that is the business understanding. Now, the next step is the data acquisition. Everything in this space, AI/ML space, data is a core thing. So for the given statement, we need to also understand what is the available data. Is there enough data available? Is the data less? Do we need to generate the data before we get into the model? If the data is not available, we need to make some people sit and generate that data. For example, in the case of human recognition, we need an image with identified areas of humans. That kind of a data would be required, where a given image and a coordinate level information that, okay, this coordinate human is present, this coordinate human is present. That kind of a data needs to be generated. So we need to understand whether the data is there or not. We need to see whether, what are the data sources? Is it in on-prem, is it cloud, in the databases, or from the online? Where is the actual data coming from? Then we generate a pipeline. Pipeline is nothing but like how the data is coming, how the data is going to flow. For example, whether the humans, it is a mobile application and people will click the photo and they'll be able to recognize the humans. So whether it is going to mobile based application, whether it is like a live camera based streaming application, how is this data going to be? So we do try to understand that here. And then the environment, where is the system going to be deployed? And then comes the data cleaning, exploration, outlier removal, missing data removal. So all of that piece comes up in the wrangling, exploration, and cleaning. In this phase, we try to understand the data in a better way. For example, we do charts, we do statistics, and cleaning of the data, identify if there are any missing data, filling that missing data. So all of that happens in this phase. So once we have the data ready, we go into the modeling phase. So modeling phase, we have a feature engineering. Now feature engineering is, we do try to create the features. Feature is basically an important part of information to the model. Model is nothing but a system that creates this learnings. Okay, whatever learning we are trying to create, that is part of a model. So feature engineering tries to generate some important feature that will be useful to the model. For example, in your data, date is coming, date of birth is coming. Okay, the system is storing only date of birth, but to the system, age is going to be more useful. Date is more human readable than the system readable. Date is not system readable. That is like a string, but age is more readable to the system. So converting a date to a age is one of a feature engineering. So that's what we try to do in this thing, that whatever is important to the model, we try to feed it, transform, binning, text, image, feature selection, like what all is important data, what all is not important data. We do try to filter it here. Then comes a model training. We try to train the model by giving different information. We make it learn the patterns. So training is a place where it keeps on learning, learning, learning. Now, when the system learns, it is not enough. We also need to see how it is able to perform on completely unseen data. Okay, so as I gave an example of school, in school, when kids are learning, they sometimes memorize the question versus answer. Okay, if they memorize the question versus answer, and in the real exam, the question is slightly twisted, but the same question, but it is twisted. So the candidate will not be able to understand and answer the question. But if he has understood what is the question versus what is the answer, then he'll be able to still answer it right. So similarly, there are some challenges that may happen in model training, and model may memorize certain things. So there in the evaluation, we try to provide it a completely unseen data and then see how good the system will be able to learn. Then deployment of this data, how do we deploy this to the cloud or on-prem or whatever the approach we decide. We like it could be a mobile-based application, it could be a camera live streaming application, it could be a batch-based system. So based on the different type of a system, we do try to deploy to the customer. And then in the real world, we keep on monitoring the system, that how good it is performing. And there are challenges like data drift, model drift. Like data drift is the data has slightly changed over the time, and the current model is not able to account to that. So we need to continuously monitor this model, and then if needed, we need to again retrain this whole model here. By improving the data, by improving the model, we need to do it again. So this is a general life cycle of a machine learning system. Any machine learning system needs to go through this a life cycle. This is like mandatory steps. You cannot skip any of the steps, like business understanding, data and acquisition and understanding, modeling, deployment. Every stage here is important. Just I would say like these are some other steps for other people, but yeah, usually people who are new in the industry, they need to look for internships and try to see that once they learn these things, how do they apply the skills. Has anyone heard here of Kaggle? Have you guys heard of a website called Kaggle? You can say yes, no. Yeah, that's great. Many of you have already heard about the Kaggle. So Kaggle is a very important website in the life of a data scientist. It has a lot of data sets. It has a lot of competitions around the machine learning, artificial intelligence, and you also get to see what people are doing, how people try to approach a certain problem statement, how they solve it. So you should have a look at Kaggle and see how people are trying to approach the problems, what kind of problems are there in the industry, uh, what are the approaches to solve. So all of those you will be able to see in the Kaggle. And also I would say be adaptable. This field requires a lot of adaptation. There are a lot of new things which you need to learn. I would not say this field is easy. Okay. There are a lot of learnings which are required, and this field is ever growing. Okay. This field is keep on growing with the new research, new uh, things that are happening. So it will keep on improving over the future. So you need to be very adaptable to keep learning as and all the new things are coming. There are everyday new libraries are coming to solve the problem. So yesterday that you solved one thing with one library, now it may be solved with a newer library. So this kind of things are happening on a continuous basis in this field. So being adaptable is also very important. Yeah. So with that, I stop and I'm open for any questions. So we can run through questions if there are any. Okay, I hope you can hear me. Okay, great, Nishan. You're done with Python. So yes, you should go next with the data analytics. There are libraries like NumPy, Pandas. So you should learn those to see like how do we process the data? How do we uh, profile the data, load the data into the system? And then what are the different cleaning that we can do. So all of those steps you should learn as the next step before you get into the actual machine learning part. Yeah, for internships, I would suggest that you should approach to different people over LinkedIn, and also you will see there's like internship shala. I think there's something called internship shala. That is one thing you should approach over LinkedIn to different people for providing the internships. So those things, even like try to do a free internships. Don't ask for money for a start. So all those things you can do to get a good hands-on at the start. Yeah, I had completed my course around like 2016, but I had not completed my AI course, I would say. When I started, it was just purely a data analytics and a basic course in R with machine learning from Great Learning. It was a very basic course. Around that time, there were not many courses available. Uh, Around 2016, there were very few people who were providing the courses. But nowadays, you will see there are many different opportunities you have to learn. There are better courses which are available. Yeah, Nishant, like as I mentioned, every topic, if I have to say like Python as a basic, in data analytics, you should learn the NumPy pandas. For visualization, there is like a Seaborn, Matplotlib. Those are open source. For advanced one, Power BI, Tableau, those things you can learn. In maths, you can learn, even you will find uh, maths for machine learning, maths for data science related articles. You can go through those, but you need to learn basic statistics, um, linear algebra, matrix multiplication in linear algebra, and then you also need to learn about the differentiations, basic differentiations and partial derivatives versus partial derivatives. And then machine learning, we just saw supervised, unsupervised, reinforcement learning. Focus more on supervised, unsupervised, more of problem statements are around that. Uh, Reinforcement learning problem statements are a bit less. In the industry, it is slightly challenging. And these are the things depends. There is MLOps, there is the DevOps related fields, and software engineering itself is a different field that requires some time. Uh, I would not suggest any, I don't have any references. I would say usually how I learn is I learn like any subject I want to learn over the YouTube. For the same topic, I create my own set of topics that I want to learn. I don't go with any one specific channel or area, because when you learn, when you try to diverse your learning through different channels, you improve your learning. So one of the things that you should do is you should list down what all topics you want to learn, and every topic try to go through some 2 to 3 sources. Okay, over the YouTube, try to go through some 2 to 3 sources. One could be YouTube, one could be article. So then your learning of that topic will be much better. So I don't stick usually with like a one single channel. I just try to diversify the topic from multiple sources. That's how I usually do. Great, great. Any more questions? Yeah, sure. I think for the 1 year course, uh, the team will share some courses with you. Okay, over the time you will get to know some good courses from the team here who has hosted this. Yeah, I'll also share some of my recommendations to them. and they'll be sharing the recommendations with you guys.
Yeah, Rushikesh. So this is Patil from Times. So we offer a few programs in partnership with IITs for AML, deep learning. So we will send you a thank you email, which will have the link of those programs, and you can have a look at it. And these are very good programs, year-long programs. You can have a look at it, and if you are interested, you can go with that. Thank you.
Thanks a lot, everyone. Thanks for joining.